So fx is x square plus 5x plus 8, x square plus 5x plus 8 in the form of what? X square plus 5x plus 8 in the form of x plus p whole square plus q, x square plus 5x plus 8. This should be opened as x square plus 2xp plus p square plus q from the identity a plus b whole square. X square does not have any value, but I can see that 5x has 2xp. X cancel 5 upon 2 is equal to p. 8 is equal to 5 p square plus q. 8 is equal to 5 upon 2 whole square plus q, 25 upon 4. So that should 25 upon 4 should go on the other side, become q. 8 4s is 32. 32 minus 5, 25 will be 7 upon 4 as what? Q. The question says x plus p whole square plus q. So values are 5 upon 2 as p and 7 upon 4 as q. Just to what we made sure that we are comparing it. Find the smallest value of a for which f has an inverse. The inverse starts from what? Completing the inverse starts from what? 1-to-1 function. The question clearly says that the domain x is greater than equal to what? A. So if the domain is x is greater than equal to a, and the question says find value of a when f has an inverse, that means the quadratic equation does not have an inverse, right? But this quadratic equation has an inverse when the question says that from what point the inverse starts. So the inverse starts from the turning point. The inverse starts from the turning point. Your turning point comes to completing the square form. Your turning point comes to completing the square form. So turning point should be 5 upon 2 negative, whereas 7 upon 4 will be positive. Because of what? The original form, that is a x minus h whole square plus k. So considering that this should be negative 5 upon 2, because negative and negative will become positive. So I can say that this becomes my turning point. This is also the domain as well. So domain from where the inverse starts. So x greater than equal to 5 upon 2. So that means x greater than equal to a. This particular value is for a from where the inverse starts. You need to also know that minus 5. So considering that this is minus 5 upon 2, and let's say this is 7 upon 4. So from this point, and the turning point that we have is the y-intercept that we have is 8. So the turning point is minus 5 upon 2. This should be 8. So the graph goes like this. And considering the graph goes upward, this becomes your increasing function with gradient which is positive. So these are a few concepts that you should be knowing with the same question that is being applied. Now, find the domain of f inverse corresponding to this value of a. Now you need to understand, we have been doing it, that domain of fx is range of f inverse of x. Domain of fx is the range of f inverse of x. Range of fx is domain of f inverse of x. Now, in this question, domain of fx is x is greater than equal to 7 upon 4. Range, no, I'll just correct it down. The domain of this is minus 5 upon 2. Range of fx is fx greater than equal to 7 upon 4, because all the values in this graph particularly will be upward in the range of y. So we can say the value of the range is representing the values of the y. So all the values of y, when x moves on the right, the values of y will be upward. So the range for this x is greater than equal to minus 5 upon 2. So that means the range fx should be what? Greater than equal to what? 7 upon 4. So Domain of fx is x greater than equal to minus 5 upon 2. Range of fx is fx greater than equal to 7 upon 4. The question clearly asks domain of f inverse x. Domain of f inverse x corresponding to the value of a. Now, domain of f inverse of x will be basically the range of fx. So if we need to write domain of f inverse of x, which is what? Same as range of fx. So range of fx is greater than what? 7 upon 4, right? Range of fx is fx greater than equal to 7 upon 4. So domain of f inverse of x will also be fx greater than equal to 7 upon 4. As I said that the domain of fx is basically the range of f inverse of x. The range of fx is basically the domain of f inverse of x. Because whenever we do the inverse, inverse is the relationship of what? Y is equal to x. Reflection in the line of y is equal to x. And whenever there is a reflection of y is equal to x, the coordinate will always interchange. The coordinate will always interchange. So this question was based on June 2001 paper 1 question number 3.